Hello, welcome. So in this video, we'll see how you can chat with your SQL database using a powerful SQL AI agent plus RAG combination. Right. So these are the topics that we'll be covering today. So the first topic is why we need RAG in the system, and then the second one is n8n workflow walkthrough. So we'll be walking through the n8n workflow that powers our system, and then we'll see the demo. And after that, you can see the workflow improvements and enhancements that could be done to improve our system. And then after that, we'll see how to connect the same workflow with flowise. Right? With just a minor change, we can actually combine flowise with our n8n workflow. And after that, we'll see the use cases of the system, where to use and where not to use. Right. So these are all the topics that we'll be covering today. So make sure to stick till the end because I think this video is going to be pretty lengthy as there are a lot of things to cover. So let's begin. Alright, so first topic is why we need RAG. So the LLMs have become really powerful nowadays that if you just give it a schema of a database and ask questions, it's able to give us a query, right, that we can run and get the data. So similarly, that works if you have a really small table, right, like 1 2 tables. Then you can just give the database schema right in the prompt and then ask some questions. It'll get you the query. But what if you have like tens and hundreds of tables, right? So that's when it gets really complicated. We can't really stuff all the schemas into the prompt and then ask questions, right? We have this context window. So that's where we use RAG in order to store all the schema in our vector database. And then once user asks any question, we go ahead and fetch the relevant schema, right? Based on the question that user asked, we grab all the database schema from the vector database, and then we just provide that in the prompt along with the user question. So this way we can able to generate the query based on the user question, right? So this is how we are going to use RAG. So RAG is really powerful if we combine it with our AI SQL agent, as this is really scalable and it can handle tens and hundreds of tables easily. So regardless of what size your database is, it can handle easily, but there are some downsides, of course, which we'll see in the coming sections, right? So that's why we need RAG, and we'll see how we can implement that in our workflow, right? And then the second topic, let's go to the second topic, which is our n8n workflow, right? So this is just one workflow and one n8n workflow where I have two different flows, you can say. So the first one is this one, which basically queries our database, gets the schema, and then inserts into our vector database. And then the second one is the one which we actually have conversations with, right? So we ask questions and then we get the answer back from the database. So before I get into this, I would like to show you the database that I'm using for this demo. I'm using this one, which is called let me just grab it right here. I downloaded this database from official MySQL website. So you have these databases here. So I have downloaded this one, which is called Sakila database. So this is what I'll be using in this demo. I've already downloaded that and have it ready in my local MySQL server. I am using SQL Ace to run all the SQL queries, right? And let's now get into this flow, right? Let's get into this and I'll explain what it's about. So this workflow, what it does is it first goes ahead and gets table schemas, right? So the way it does is, let me just show it to you in a raw manner. So if you just do show create table and then any table name, for example, I'm going to use the first table, is called actor, right? So if you run this query, what you're going to get is the actual schema of this table, right? If you just copy over and run the same query again, so it's going to create this table with these values, with these columns and constraints and indexes and all that. Right. So this is what we want. So this basically holds the schema of this table. So this tells us how this table looks like, what all details it has, what all columns, data types, indexes, foreign keys, any constraints. So all that details is present within this result, right? So this is what we want. Right. So in the first node, what we're doing is we're actually going through. Let me open this up and show what the query actually does. Right. So let me just copy this, and if I run this query, So you can see the initial query that we ran here. It's called show create table actor, and then it's going ahead and giving us this query for all the tables, right, which we can just directly run and get schemas for all these tables. So this is what we're doing, right? So we're just looping through all the tables and then coming up with this ready-made query that we can directly execute to get schemas for each of those tables. So that's what we're doing in the first node, right? So in the first node we do that, and then we get all the executable queries, right, for each table, and then we loop over each record, and then we individually execute them, right? We individually execute these queries: show create table actor, show create table address, and we individually get the schemas for this table, right? And once we get the schema, we go ahead and directly insert it into our pinecone vector database, right? And let me actually show you how it looks like. Yeah, it's this one. I've created this for this demo purpose. It's called n8n db agent, and this is the index, and I've already inserted the records, as you can see. So if you just see here, if I open this up, oh, sorry. So if you just hover over this, right, you can see the complete schema of a table, right? In this case, it's the film text. So the same way, if I just hover over this one, any of this entry here, it gives me the complete schema of a particular table, right? So this is what we need. So we have all the schemas ready here for individual tables, and then once we loop through all of them and then insert all the data, it's done, right? We now have all the schemas of all tables from our database. So there might be a question saying, why can't we just aggregate all the queries, right? For example, just come up with a 1 mega schema document where we just loop through each table and then come up with one document and then insert that one document into our database, right? Why can't we do that? The reason is pretty simple. If we do it that way, then while we are chunking the text, right, the large document that we got, while we are chunking it, there might be a possibility that a single table can be chunked into different parts, right? For example, there's a big table called actor, and then while chunking, the first chunk has the first part of the schema, and then the second chunk has the middle part, and then the third chunk has the last part, right? This way all the chunks are being just being messed up, right? We don't really have the schema or the knowledge that we need for individual table, right? When we do the vector search while getting the schemas, right, we need complete information of a table in order for us to come up with a really good query. If the schema is all messed up and it's just scattered all across, it's going to be really hard for us to find all of them. Even if we find, then we have to fetch n number of chunks, like lot of chunks, and this will make our prompt even heavier. So this is why I'm doing this. So I'm making sure I'm looping through single schema for each table and then inserting one by one so that each chunk has a schema of individual table, right? So this way everything is segregated. So the number of records that you see in your index, right, in your index here, it says 16. It's always going to be equal to the number of tables that you have in your database. So each table schema is a record, is a chunk here. So this makes it easier for us to get the schema in order for us to push it into the prompt, right, while we make requests to our LLM. So this is the reason why I'm doing this for individual records. Right. So let's talk about our primary or important workflow, which is having chat with the database itself, right? So this is that workflow. If I just zoom out a bit and show you how it looks like. So if you just take a look at the nodes that we have. So this is the AI agent, which is connected to an LLM. Here I'm using Anthropic. I'll explain why I'm using specifically this model. And then we have this window buffer memory to hold previous conversations data. And then this is where we are making requests to get our schemas from vector database, right? So pinecone vector store, and then OpenAI embeddings. And then here I just have a simple LLM chain. This is called as fixed query and query enhancement. I'll explain what these are all. And this is connected to again Anthropic model. I'm using Claude 3.5 here. And then over here, the request is being branched out into two different paths. So one is if the query which was generated is executable and valid. If yes, then it goes to this node. This is the one which actually executes the query and then returns it to another LLM chain, which summarizes and gives back the result. So this is just a fallback LLM, which just handles irrelevant case that user might have asked, which is not related to the database itself, right? So this is how it looks like. Now let me actually take you through each one of these nodes and tell you what it involves. AI agent is the first node that we have. So this is the one which takes the user question directly, and then this is where we have our system message. This is a well written prompt with all the examples and different cases on how to handle different scenarios, right? So this is how the prompt looks like. You're an expert SQL query generator, and then I'm just setting up a role and also giving it some information about the kind of database that we're using, so that it knows it's able to differentiate when to use the database and when not to, depending on the question type from the user, right? And then I'm setting some responsibilities and goals, converting natural language into logically correct MySQL queries. And then I'm using this tool. It's called retrieve database schema, which is nothing but our pinecone vector store over here, right? I've named it in such a way. It's called retrieve database schema, and then I'm asking it to use that tool to get the schema, right? Database schema. And then I'm also giving it some additional information and instructions saying use limit to limit the number of records that you get from the database, and also use join, group by, order by. These are all advanced keywords that we use to join between tables and perform some advanced queries, right? And then this is really important, which is no data manipulation queries, meaning this agent is specifically meant only to retrieve data. It should not perform anything else. For example, it should not insert, update, nor delete. It's only meant for retrieving data, right? So I'm giving it specific instructions on when to use this tool and when not to use this tool, right? So these are all some cases. And then I've given it some examples, some example queries and outputs, right? So if you ask something like get all actors whose last name is Smith, and the output is going to look something like this. Select actor ID, first name, last name from actor. This is the table name where last name equals this one. Similarly, I've given it some examples going from simple to complex ones. Like for example, here we are using joints, which is pretty complex. And then I've also given it example of irrelevant question. For example, if someone asks how to make blueberry cheesecake, then just returns empty string. It's not going to continue further, right? And also set some strict boundaries and rules on when to use the tool and what are the different types of restrictions, limits that this agent is bound by. And then final notes, right? Make sure to be friendly, professional, and maintain neutral tone, right? So this is how the system prompt of the AI agent looks like. So now it has the query with it. So what it does is it passes the query to the next node, which is this fix error and query enhancement. So this node is responsible for taking that query and fixing for any errors and also enhancing the query, right? If I just expand this section here, so this is what it looks like. You're an expert SQL query validator and optimizer. So your job is to analyze, correct, and enhance MySQL queries and maintaining their intended functionality. So I've given it again responsibilities and goals, other key information and instructions. Again, I'm asking it to not to manipulate any data. For example, insert, update, and deletion are not allowed. And also asking it to use indexed columns, right? For example, if there's any column which is indexed, so I'm asking it to use it so that the query is optimized. And again, I'm giving it some examples here. If the query looks something like this, then what should be the action, right? And what should be the optimized output look like? Similarly, I've done it for other queries as well. So this is an incorrect query example. This is a suboptimal query. This is an inefficient join. So probably this can be further optimized, and then the output would look something like this. Right? And then here we have irrelevant or invalid SQL statement. Right? If it gets any of that as an input, then it just gives an empty string as output. And I'll also tell you how we'll handle this empty string next, and also set up this strict boundaries and rules and final notes again. Right. I also forgot to mention a little minute detail here. Right. So in the user prompt here, along with the chat input, we're also providing the current date and time. Right. So this is being fetched from. This is a small JS function that I've written. It's not a function. It's just a simple JS code which gets you the correct time of wherever you are. Right. So in my case, it's this date and my time zone. It's better to provide this in the prompt, because let's say if you ask something related to date range filtering, right? Let's say in our case, if asks for get me all the films which was released in the last 3 months. If you don't provide this data, it doesn't know the current time and year, right? In order for it to come up with the query, and it's just going to assume some random date and year in 2022 or 2023, and that's going to give us the wrong result. So to avoid that, I'm just providing this little JS code in the prompt so that it knows my time and time zone. Right. With that being said, now I'm going to the next node, which is this if a simple check, right? If check. This is a really simple check basically. So in this node, we've seen that if there's any invalid query, right? If this node receives any invalid query, then it just returns an empty string, right? So this is what we're checking here. If the input of this node starts with select, right? So any valid read SQL query will always start with the word called select. It's the standard, right? So I'm just checking for this one. If the input received by this node starts with the word select, then that means that it's a query and it's been validated by the previous node, right? So that's what I'm checking here. If it has this word called select, then I'm just moving it towards this node, which actually goes ahead and executes the query. Otherwise, it just falls back to a simple node here. Let me just cover this one first. It's just a simple node, simple LLM call that makes a request to ChatGPT, I believe. Yeah, this is a simple system prompt, where the goal of this prompt is to encourage users to ask questions specifically related to retrieving data from database. Right? If someone asks some irrelevant question, right? Like for example, if they ask how's the weather today, right? The response would be like great question. However, designed to help retrieve data from database. Let me know what database query you need. Right? No matter what question they ask, it'll always point them back towards the main purpose of this workflow, which is to ask questions from the database. Right? So that's what it's meant to do. And once this is covered, let's go back to our execute SQL query node. So this node receives the query which was previously validated by other nodes. Right. So it receives the query here, and then once it receives it, it just executes it. And once it executes, the output of it will be passed towards this summarize node, which is again a simple LLM call, right? Where I just pass the user question. If I just zoom close this one, for example, here in the user prompt, right? I'm just passing user question as whatever the user input in the chat box, and then the response from the previous node, which is this one, execute SQL query, right? I'm just providing both and then asking it to summarize the details, right? If I just open this up and show you the system prompt of how it looks like, so this is what it looks like. Pretty basic. So I'm just telling it how to summarize the details based on the question and answer. Once it does it, it just summarizes and gives back the result, right? And that's it. So this is how the entire flow works. Next thing is we'll actually look at the demo and see how it performs. Right, now let's look at the demo and see how it handles the cases starting from simple to complex queries. So for this purpose, I also have my SQL client running so that I can execute the query and compare the results. Right. So let's start with a simple question. So let's just see how many actors we have. Let's start with that one. If I go over here, and as you can see on the bottom here, it says 200 rows, right? And even if I just run the same query here, select star from actor, it gets me 200 rows, right? So let me just go ahead and ask it the same. Chat, let me refresh this. How many actors are there? So let's see how it works. So it's now getting the schema from our vector database. As you can see, it takes a little bit of time because there are a lot of steps involved in between. It's working on the last node. Yep. So it came up with this answer. It says there are 200 actors, which is correct, right? And then let's uh, go ask it a little complex, a little difficult than the first one. Let's go over here and see this table holds film category. So this film category table holds uh, relationship between film and category. So it basically tells us which film belongs to which category, right? So let me just see here. This film is called Academy Dinosaur, and it belongs to this category called documentary, right? So let me just ask it this. Let me copy this. Go back. Academy Dinosaur belong to, and let's see what answer I get back. So the right answer for this question is documentary. Let's see what it comes up with. Yeah, this is going to be time consuming. Yeah, there was an issue on in one of these nodes. Let's see what happens. It's executing the last node. Yeah, the Academy Dinosaur belongs to the document category. Yeah, this is correct. Something went wrong here. Okay, network problems. Okay. API outage. Oh. Okay, never mind. Let's keep trying. Right, we got that answer. That correct answer now. Now let's increase the intensity. Now let's. So we have these three tables here. It's called film, film actor, and film category. Right. So here in film actor, so I think it's an association between the actors and films, right? It's like which actor acted in which movies. So I think these are all the relationship here. So let me go back and pick a particular actor and ask Kevin. Right? Let's pick Kevin. Let's ask in how many movies did Kevin act in? Right? Right. Kevin Bloom has acted in 21 movies. Wow. Let's check it. Kevin, right? Kevin Bloom. Uh, we have this film category. Let's grab this 25 ID. Film category. His ID is 25. Sorry, it's a film actor, I believe. Film actor, yes. Where actor ID 25. You got 21 rows. And yes, this is correct, right? Kevin Bloom has acted in 21 movies and we got 21 rows. Perfect. This is working fine, right? So as you can see, it works fine. Uh, it can able to handle simple to complex. And of course, this workflow is not completely perfect, right? There's still a lot of room for optimization and improvement. So whatever we have seen till now, it's been going fine and perfect, right? We've given it questions starting from simple all the way to a complex query which involves joining different tables, right? So this seems to be working fine. And yep, let's now move on to the next topic. So let's move on to the next topic, which is workflow improvements and enhancement, right? So let's talk about this particular workflow, which is inserting DB schema into our vector database, right? This one over here. So if you just see, let me just go back to the notes. So add vector update logic. Currently, we do not have. Okay. So what we have currently is just insertion, right? We don't have the logic of updating the vectors that already exists in our vector database, right? So that particular logic is missing, so we can add that logic into our workflow. Probably just we can branch it, we can create another branch saying, if vectors already exist in the database, then just update it if it has changed. Otherwise, just skip it, right? We can add a logic like that. So right now what I'm doing is just inserting every schema into our vector database, and then if I had to refresh them, I just go ahead and delete this namespace, right, and then reinsert. This is not the optimal way of doing it. What you have to do is you have to consider that updation case right here in the workflow, meaning if something has changed, if your database schema is changed, then you need to make sure to update that particular vector in your vector database. Otherwise, just skip it, right? If it doesn't exist, if you have created a new table in your database, then it should also insert that new table schema into your vector database. So that case need to be considered here. So I'm missing that. And then over here again, so we need to update the vectors when actual database schema is also updated, right? So for example, your database schema is updated, right? Let's say you add three more new tables into your database, right? Over here into your database, you add three more tables. So you also need to make sure to insert those three newly added tables into your vector database, right? So how would you do it? So right now it's everything is happening on click. What we can do is we can just add another node called as cron, right? A schedule trigger. So which basically runs on a particular interval, and then you know just executes these workflow, meaning it just goes ahead and fetches for all the tables, gets the schema, and then inserts it, right? So one way of doing that on a regular interval is by using this schedule trigger. It's also known as cron. So what you can do is you can just connect it here, and then for you can just specify the time here, or you can just go to cron tab guru, I believe. Yeah, this is the one where you can get the cron expression, meaning this expression means every 5 minutes. So usually you would need to run this when the load is a lot less, right? When there's less load on your database, that's when you have to do. Usually at around 2-3 a.m. midnight. So that's the ideal time, right? So you can just use this expression over here and then set it to run, and then this cron will keep running every night. Or you can just, if you want to make it more frequent, then you can just run every probably 6 hours, every 8 hours or something like that, depending on the use case again. So you can just add that node to keep your database in sync with your vector database. And then the last step is only refresh the vectors if the actual database schema is updated. Again, like I said in the first point, which is we also need to consider that update case where, if the actual database schema over here, right? If the schema of this particular table is actually changed, only then you have to update. Otherwise, you need to skip it, right? Although what happens is, if you just keep updating the same thing again and again, it's not really efficient, right? That method is not really efficient. You can simply add a condition, or what you can do is the other way, which I've mentioned here, is to use Redis in this case. What you can do is you can just add a Redis node, right? You can set up Redis connection and set up the Redis node over here. What you can do is, before inserting, right, you just take the schema and make it into a hash, right? Any hash, probably base 64 or something like that, or MD5. You can convert that entire schema content into hash and then store it in Redis, right? And then whenever this workflow executes the next time, and then you check for the same content, and then you convert the same content into hash again, and then compare those two hashes, right? If the hash is the same, meaning that nothing has changed, right? The content is same, the schema is same, so you can just skip that part. You don't need to insert that, you don't need to make an update or insert into your vector database. If the hash mismatches, it means that something has changed in your schema. Then you can go ahead and update or insert or do whatever you want, right? So this is one way that we can optimize the way we insert and update uh, data, right? So all these methods are, again, these are all best practices in order for you to build highly scalable and available systems. So that's how things work. So these are all the improvements for this particular workflow, which is inserting data into our vector database. And then workflow improvements and enhancement for our important main workflow is this one. So let's see what are they. Try different chat models and play with temperature. Again, you can. So right now, this workflow works fine as we have seen in the demo, but it's not the perfect again. So you just need to keep testing and testing with more and more data and more different types of questions. The result can vary every single time, so we need to keep testing it and make sure we maintain the optimized result every single time. Basically, make sure the system is reliable, right? So for that, we can just test this as much as we can with different models, different temperature. We can change the temperature. So here I've used Anthropic chat model because, when it comes to code generation, this is much better when compared to what we have with the uh, OpenAI, the Chat GPT models, right? So that's the reason why I've used Anthropic here. You can just replace these with different chat models and see what the results are like, right? So you can just keep testing with different models, keep playing with the different temperatures in order to see how the entire flow works, right? And then on error during execution of query, loop back to query enhancement node and generate a new refined query and try again. So what this basically means is, for example, right now, if something goes wrong in this execute SQL query, it's just going to raise an error or pass that error message to the summarize node directly, right? So that's what happens. What we can do is, if there's any error in this node, we can just loop back to this uh, query enhancement node and ask it to rewrite the query, right? So we also pass the error message to this node saying this is the error message we are getting. So just rewrite the query this time and make sure it's correct, right? And then it just rewrites it, passes it again, executes it, and if it's successful, then we just pass it back to our summarize nodes. That's one improvement we can do. And the third point is, again, monitoring the system using Langsmith, right? I am not really sure how to connect Langsmith for this in n8n workflow, but that's one way to basically monitor the entire system to see what's going on with the with the entire workflow, right? And based on that, based on those feedback, we just keep improving the entire system, right? Perfect. Now, next thing is how to connect this workflow with flowise, right? So first I'll cover what we have to do on n8n side, and then I'll show you how what we can do on flowise side, right? It's pretty simple. So there can be a lot of reasons where you would like to connect this system with flowise. Predominant point could be that uh, flowise offers a better chat interface than n8n, right? Probably for that you might use flowise, and the backend still stays on n8n infra, right? So what we can do is we can just take this part, right? We can just move this part into our flowise. These can be constructed into sequential agents, right? This is a sequential agent and this is another sequential agent connected to each other. And then on n8n side, just replace this with webhook, right? So what we can do is just remove all of it, and then instead of that, just add a webhook node here so that it accepts data from outside. Let me redo it. And then at the end over here, just add the respond to webhook node, right? We have these two nodes, I believe. Yeah, the webhook node goes in the front, and then this respond to webhook goes at the end, right? And then we can connect these two nodes to this respond to webhook. So whatever happens in between this, the result will be passed back to respond to webhook, and then that will be passed back to the request that was made, right? This is what we have to do on n8n side. And going on to flowise side, if you just go over here, like I said, this particular section that we have can be added into sequential agents. If I had to show it to you this way, so this is sequential agent 1, this is sequential agent 2, they're connected to each other. And then sequential agent 2 is connected to a custom tool, right? Custom tool, this is what makes request to our n8n webhook, right? So what it does is the sequential agent 1 takes in the chat input. So the first agent is responsible for getting the schema and then generating the query. This does the same thing, and then it passes the first iteration of query to the second agent. This basically refines it, right? Once the query is refined, it passes this refined query, right? This refined query to our custom tool, and then in this custom tool, it makes a request to our n8n, right? n8n workflow. So that's why we set up the webhook there. So in this request, we just pass our refined query, right? We're passing this refined query to our n8n instance here. And then once we get that from here, again, we have this check. It checks whether the query that was passed is valid or not. Based on that, it just routes routes it to different set of nodes, and then we get back the result. So that's how we can set it up on flowise. It's pretty simple. All you have to know is to just get rid of the first part, move it to the flowise, and everything should work fine. Right. Next, talking about the use cases, right? So we've seen in the demo that, if we are planning to use this workflow in a customer facing system, right, then it might not be a good uh, approach, because it might lead to a poor customer interface, because we have seen clearly that it takes a lot of time. Sometimes it takes 20-30 seconds, and sometimes there can be a api outage. We have seen that also in the demo. If something goes wrong with the api, and then customers, they just keep typing question after question, and then there's a lot of load on your system, also on the main llm systems, right? So the entire infrastructure just collapses that way, and then it basically leads to poor customer experience. So if we are using this workflow for building customer facing applications, right, so I wouldn't recommend this for a customer facing app, but it's very ideal for internal business use case. For example, developers, data analysts, and data enthusiasts, to access data effortlessly without writing manual sql queries, right? Developers can just use it, like they can just write queries in natural language and get the data. And that's one use case. And data analysts, I believe, is going to be more useful for these set of people, and then data enthusiasts. So anyone who would like to access data from the database without having to write manual queries, SQL queries, they can just ask it in plain language and get back the result. So this is one of the best use cases to use it in an internal purpose, internal business use. And then this system can also be used as natural language to SQL query generation engine, right? I'll show you how. All you have to do is just delete this node, right? If I just, yeah, if I just do this, right? So the output right now will always be the query which was executed, right? So what you can do is you can just ask question and then get back the result which is the query itself, right? So this way you get the raw query back, and then you can just modify it or optimize it or do it whatever you want. So rather than the actual summary of the data, you're getting the query itself. So the raw query is being returned. If you just run this, sorry. So if you just run this workflow now, you're gonna get the raw query as the output. So this basically works as natural language to SQL query generation engine. All you have to do is to drop that last node, this one, and that's it. Next, and I believe that's it. This was a pretty lengthy video, I believe. Covered a lot of topics. So if I had missed something, um, just let me know in the comments. Or if you have any other questions related to this workflow or anything else, just let me know. And you can download this n8n workflow from the description section. It's available there. And then if you want to work with me to build practical solutions and AI systems, right, like this one, and even much more optimized ones than this, then you can contact me. This is my email. And I also run an agency called Falcon 27. You can also book a call directly. If you want to talk to me or have anything to consult, then probably you can just directly go ahead and book a call with me over here in this site, falcon27.com. And once you've seen this video, you might have got some more ideas and questions. Then you can just drop them in the comment. So that will basically act as an idea or inspiration for me to make more videos on those topics. So if you have something like that, if you have any ideas or inspirations that you would like to see built or made videos about, then you can just drop in the comment or let me know through email. I'll try to make more videos on those topics. So I majorly make videos on flowise and n8n. So I'd like to use both of them in combination. So that's a deadly combination, like I said in one of my previous videos. So if you'd like to see more, just feel free to drop a comment, right? And I think that's it. I'll see you in another video. Until then, take care. Bye.